My name is Pierre Paul. I am a developer for Unity. I work specifically on the Mecanim technology. Today, I want to show you some brand new and super exciting features that we added inside of Unity 5.0. And I also want to show you like little tips and tricks that you can use when you work with Mecanim. So, the new stuff. I'm very excited to show this to you today. Here's a small list of the big stuff that we did for 5.0. So first of all, we have what we call state machine transition. So for those that have used Mecanim a lot, it often ends up with a lot of connection between states. It's kind of a big spaghetti mess that you get using Mecanim. And one of the reasons for that is that all transition in Mecanim were from one state to another state. So we wanted to give you the ability to have a higher level of control over those transitions. So we added what we call state machine transition. So basically now, you will be able to connect one state machine to another state machine without really taking care of what's inside of the state machine. I will show you a little bit later how this works. We also added state machine behaviors. State machine behaviors allow you to add some code directly into your state. So now you have this state machine behavior script that you drag on your state, and it allows you to implement callbacks like on-state enter, on-state update, on-state exit, and a couple other ones. We also added the ability to author root motion. So again, this is super interesting when you do sprite animation, simple 2D games. So you're now able to convert animation into sprite animation. At last, we added an API to create and exit everything that is related to Mecanim. So make it state machine, animation controller, layers, parameters, blend trees. You can all do that via script, so you can have your own tool to exit Mecanim data. And we also added a new type of blend tree, which is called the Direct BlendTress. So enough with slide. Let's just jump inside of Unity, and I'll show you how this works. So first of all, one of the things that you will notice is that we revamped the tool a little bit. So now you have a new parameter window where you can reorder your parameters. You can find some parameters like this. So for those who had like thousands of parameters and it was kind of difficult to find, I hope this is a welcome addition to our tool. The same goes for layer. You can now reorder layers, which is something that was kind of lacking in the previous version. So you can reorder layer. We have a nicer interface to the layers. So this is the refactor of our controller tool. So the first thing that you'll notice when you first open a Mecanim state machine is that you now have entry nodes and exit nodes. So this is part of what I was talking before, the state machine transitions. So now, when you enter a state machine, for instance, let's jump into this idle state machine here. So when we go inside of this state machine, there's an entry node and there's an exit node. So when you have a transition that is going inside of a state machine, it will evaluate first the entry node. And the entry node it's like an empty state node where you can put outgoing transition with condition like any other Mecanim transition. And then you have the exit node. So when the animations are finished in your state machine, you just make a transition to the exit node. And in a similar manner than for the entry node, it will look at all the outgoing transition of that state machine. Let's just press play to see a little bit how it works. So you see here that I have a idle state machine. And the way it works is that once it's done playing its animation, it's going to the exit node. And I have a transition here, as you can see, going out of idle and back into idle. So this is the way that you implement like a random idle state machine. So it plays the idle animation, and then goes into the exit, and then goes back into the entry node, and then it can potentially select a different idle animation. So if we let it run a little bit like this, and we also have code, which I will show later, that randomly determines the number of loops that it will stay in idle. So now you have an idle that really, like an idle state machine that is self-contained. So you have all the enter and the exit node. It's easier to share, to take the state machine and copy it into another state machine. And you also have the ability to manage the randomness. And how you manage the randomness is that you use state machine behaviors. Let's just take a look at this one, for instance, where I added a script to this, all those nodes here. Again, I don't want to go too deep inside of the code because code is boring during a presentation, maybe, I don't know. So here you have the onState enter, where we just randomly determine the number of loop that we want to stay inside of that, on that state. And here, after this certain duration is passed on the state update, we trigger the transition to go out of it. Again, a very simple example, and I think that we can do really, really crazy stuff with the state machine behavior. Like, you're not forced to use Mecanim only for animation. You could do any kind of logic in your game that uses state machine. You can just pop up those state machine behaviors inside of those states, and then you have the live link from Mecanim. You can easily debug your game, and it doesn't have to be animation. So I think it's pretty exciting. So I have this guy here that is randomly into idle. Now he's beginning to be sad because it's been a while that he's in idle. I will just show you transition to other states. So now I can fight, because I have a fight state here. Again, if we go into the fight, there's a lot of fight moves, and he will randomly go into different fight moves. So we see here, it's kicking like this, doing that. But you know, I think that the fighting move is kind of lacking a punch. So I would like to make it a little more fiery. So what I will do is that here on the fight states, I have a state machine behavior here that is called trail effect. So here, let's go inside of this script. So again, super simple. You have an onState enter, where you instantiate a trail renderer. On the state exit, you destroy the trail renderer. And on the state IK, I could have used the onState update, for instance, but I wanted to show that there's also an onState IK. And here, I just changed the position of the trail renderer based on the IK position of the feet. So here, if I enable this, show trail, and then the guy now has Firefoot attack. It's a very powerful attack, like this. So again, I did this script once, and I just took this script and put it on the different fight animation, and I'm done. So you can see state machine behaviors like as abilities that you can add to your state machine. And more than that, if you think of it, I'm sure that in your game you have a certain huge function that does, if I am in that state, do that with keyboard input. Like, what does fire button mean in idle is kind of different than when you are in a swim state. So now, inside of the state machine behaviors, you can put all that logic that handles the keyboard input based on what current state it is. So I think it will really remove this ugly function that you are ashamed of in your code, that this, if I'm in idle, I do that. So it's a super powerful addition. So now we have the guy that is fighting like that. He goes back to idle, but he's not fighting anything, so I think it's a bit boring. So let's pop an enemy in there. So here I have an enemy, which is the television. It's everybody's own enemy. So now he's going to fight the television, having a hard time, but at some point he's going to, oops, again, it's a fierce opponent. So, but sometimes he's going to kick the television. Again, I missed my shot. I made the game really complicated to win, so I hope this time it's gonna work. Not again. Damn. One last try. I hope it's gonna work. Because normally he hits the television, and for some reason it doesn't work. Now let's try again. Yeah. Phew. But, as you've seen, it was kind of a bit boring. He hit the television, and I would have liked to have like an explosion effect. So again, a little trick that I will show you, a super simple trick. So I have here an explosion sprite here. And I created an animation on it, a very simple animation, which is a scale curve. So it starts at a scale of 0, and at some point it gets a scale of, I don't know, 20%. But the twist is that I added an animation event at the end, and the animation event at the end, it disables the object. So for me, it's a way of just like you create, when the explosion happens, you just create the object. It will automatically start the Mecanim state machine, which will play this animation. Boom. You can take a look at the super simple state machine, which is only the boom animation. It will play it, and when it's going to reach the end of the animation clip, it's going to get the disable event, and the disable event, it does what it says. It disables the explosion. So here I have, I think here in my explosion script, I have a disable which just deactivates the game object. I also added a little explode function that randomly changed the sprite. Not randomly, I think. No, it's not randomly, but it changed the sprite that is actually popped. So I have an animation that is only scaling. So this works on any kind of sprite, and it scales the explosion, and it disables the object. So let's try this. Hopefully, my character will be easily more good at fighting the television. This. Let's show the trail, show the enemy, show the explosion, and here, boom. So again, very simple script, and now you see the object is disabled. It's not in my, it's not in this, it's not annoying anymore. It's not taking space, and pow, a smaller one. You see, it's a different animation. And then he's dancing. Again, for the dancing, let's just check this again. I think I haven't shown it. The dancing is kind of the same thing, that randomly choose a dance animation. So another thing that we've just added, and I did not have time to put it in this demo, is that you're also able to put state machine behaviors into entry nodes. So meaning that you will be able to do this kind of logic to determine which is the next state that you should go into, but you would do that into the entry node. So you can add state machine behaviors. And what is interesting is that you can chain the entry nodes by just, if you enter, you go to the entry node, and if you transition to a state machine, it will also call the entry node state machine behaviors for the other state machine that is going into. So you can have really like random logic that chooses what animation to play, or not any kind of logic. It doesn't have to be random. In life, some things are not random, I guess. So let's continue the fight with the evil television. So now I will have the enemy damage me. So I'll do that. And then I will be trapped inside of the television. So you see, and then there's a lot of bugs that are annoying my character. So let's take a look at how I animated the bug. So let's take this bug here. So the first thing I want to show is how do we author root motion. So let's create a new animation for that guy. So I'm going to hit record, up, sing. Again, I'll do this. So let's do a simple animation that just translate in Y. So again, if I play this right now, as we would expect, we would have something like this. And the reason is that it's a transform, normal animation, a transform animation. It's in absolute, so the movement doesn't accumulate over the loop. So what we want to do is to take this and convert that into root motion. And we've made that really, really simple in 5.0. I'll prove that to you. So you take the animation and you just generate root motion curves. So basically it will take the animation, the translation and the rotation animation on the game object and convert it into root motion. So did I press it? No, I'll press it. So now it would be written, root motion is driven by curves. And then inside of the animator component, I will click here, apply root motion. And if I press play, if everything goes well, I will have root motion. So this is a simple one that it's only a fly going up, but I think it's super powerful to have that. A small detail that I did not show is that we can do sprite animation. So here, this was in 4.3, but I'm just going to show it because I like to use it. So here, again, super simple to do the sprite animation. I will go here. I have a sprite somewhere. So here I will put a going north, and north like this. Just have to add it twice for the end. So here, if I press play, So you see that the fly is moving in a very realistic way, like this. So you have a simple sprite animation. So now I have the bug that is only going upward, which is not enough because I would like to have the bug going in all directions. So we will use the new feature that we added in 5.0, which is the Mecanim API. So again, I'll dig a little bit inside of the code. So here, I created a simple script that uses the Mecanim API. Again, I will not go to all the details, but just to show you that it actually exists and it's working. I create an animator controller. Here I would add two parameters, velocity x and velocity y, of type floats. I would create a new blend tree. I would set this blend tree to a simple directional 2D. And you will see that 2D blend trees, which we added, I think, in 4.3, I found them really useful to do sprite animation. In this example, I will use it, and you'll see that for me, it's very powerful to use that. And it's not something that we thought about when we did the 2D blend tree, how well they will work with sprite animation. So here, I create the blend tree, I set the parameter, and then on the 2D blend tree plane, I set the child animation at their proper position. So this creates a little tool here that I call the navigation builder. So I will specify the target, so this is the bug here. I will add, so I've shown you an going up animation. I already have those animation prepared for all directions. So let's go here. So here I have my animation. A really high-end feature that we also added in 5.0, it's now you're able to zoom in and pan and move around in the... I know it's crazy advanced stuff, but I am very sorry that it took us all this time to do that in the inspector. So yeah, so now you have all this. I have all these animations that are ready northeast. So I will just put them in the small tool here that I did. So north, northwest, south, southeast, east. So I will press create, and what it will do, like I've shown you in the code, it will create a new controller, it will create a blend tree, it will set it to 2D, and it will put all these 8 directional animation inside of the blend tree. Let's do that. So here I have a new controller. If I go take a look, so it has one state, which is called move, one layer. If I go inside of the state, it's a 2D blend tree. All the animation have been placed at their proper position. If I take a look here, they have been placed in their proper position. And if I press play, oops, and I do this. And again, what is interesting, the way that the 2D blend tree works with Sprite is that it will only display the Sprite animation with the highest weight. And I guess this is what you want, because blending Sprite is kind of showing 2 sprites at the same time would be weird. Maybe it's a bit slow, like this. Yeah. So there you go. We have a kind of a top-down controller for a sprite animation. And the reason why I use the API and I did my own little tool here to create this is that, sprite animation is not really retargetable because it's sprite, and you want to have different sprite animation for each of your enemies or characters in your game. So to create a small tool like this, it requires, I don't know, 100 lines of code, and could have used less lines of code, but it's super simple to have your own little tool that just creates your blend tree. So now I could have many different type of enemies, and it would take like a couple clicks to generate them. So let's go back to our little game. So where were we? He was stuck in the television and being attacked by bugs. So here, so you see the bugs here that are animated. We can take a look at them. Super simple. It's the same blend tree that I've shown you before. I have a super simple script that just makes the bug move randomly based on a random target inside of the television. Again, super simple. And it sets the float parameter to the animator. Very simple. So now, I guess you've noticed the character has like a bummed out face. He's kind of not happy to being stuck in that. So what I did the way that I implemented that is that I have a facial animation layer, and it uses BlendShape. But it uses BlendShape with a direct blend tree, which is something that is new in Unity. So I will show you a bit how it's done. So we added BlendShape in 4.3, and the way that BlendShape works is that you have here on the model, on the mesh of your character. I'm just going to go deep here, here, and here you have all these blend shapes that drive the character. I think it's too much control, and this is not the thing that you want to publish to your game logic. I would not like to have my game logic like to go and directly write to the skin mesh renderer and change those values. I think it's overly complicated, so I wanted to have a higher level of control over that. And using Mecanim, State Machine, and BlendTress, for me, it's the proper way to do that. So what I did is that I did super simple one-frame animation using the blend shape. So I'll just show them to you. So facial animation. So here I have, it's one-frame animation that uses many blend shapes. So you see here, you see brow, he's angry, you see mouth open, smile. And if we take a look at the smile is kind of funny. Yeah? So if we take a look at the animation window, here, only one frame, it basically sets the value of 100% for some blend shape and 0% to the other one. So I've created like 5 animations, and what I want to do is to control them in-game with a higher level of control. So I put those animations inside of a direct blend tree. So to have a direct blend tree, it's a new blend type here. So you have 1D, the many types of 2D blend tree, and you have the direct blend tree here. So what I did is that I put the 5 animation in them, and I binded them to a parameter. So the use of a direct blend tree is when you have animation that are, I would call them exclusive, so that they touch at different places of your character, and blend shape are exactly that. So here, if I press play, and I control the blinking, we have a zoom, let's use it. So here, we have the blinking, and you can blend them together like this. Because before, with blend trees, it was impossible, because blend trees always blend the 2 child of the blend trees. Now you can directly set the weight of the animation. And this opens up a world of possibility, because for people who want to have their custom blending nodes, what you would do is that you would create a direct blend tree like that, and in code, you could implement whatever kind of blending that you need. So it really opens up possibility. And then what is interesting also is to use those parameters in a state machine behavior. So here, in the facial expression state, I've added a little script here that gives an even higher level of control. It's basically happy and angry. So again, it's a bit overly complicated for nothing, but it takes the value of happiness and converts it into weight for smile and mouth open and so on. But we also added blinking time. So we have a random blinking algorithm that we did here. Again, we could have split the state machine behavior into many different scripts and just add the ability to different states. So if I want to be in a certain state that I need blinking, I would just drag the blinking state machine behavior inside of that state, and blinking would occur. So let's take a look at this in action. Like this. And now what I did is that I attached the happiness value based on the score. So you see here, when he kills the bug, he's getting happier and happier. And then he's really happy. And then, oh yeah. And then he's saved from the television because he killed all the bugs. Thanks. So another thing that that you can do with the state machine, with the API for Mecanim, is that you can actually take the Mecanim asset, the state machine and the blend tree, and you can save them to disk, and you can reference them in other state machines. So it's really like this will also help to have like easier source control. You want to have many people working on different parts of the state machine, so you can save those state machine as different assets on the disk and reference them and share them between state machine. To be completely honest, we don't currently have a nice workflow around this. You have to use the API to do the referencing, but in the future we want to have a real workflow so that you're able to lock some part of it, to like just edit some state machine and know that it's referenced and have like visual feedback from that. We don't have this at the moment, but at least you can start to do it via the API. And if you think of it, now with state machine transition, with the API that allows you to save the assets separately, and with the state machine behaviors, you really have the ability to have state machine that are really self-contained and super easy to you add this to an existing state machine, you add the transition to this, and you're done, because all the logic that handles, that is needed to have the state machine run is already embedded as a state machine behavior. So it's really like an important step in having reusable state machines. So we also did a lot of other features inside of 5.0. So these were the biggest one. But we also added an improved IK that you can now have what we call an IK hint. I think the other words for it is a IK role or something like that. There's many ways to call it. So we added this. We also added transition interruption improvement. So what does this mean? Is that in the past, transition could only be, were atomic or not, and could only be interrupted by transition in the same source state, current state. So we now added the ability to be interrupted by the transition into the destination state. So there's a drop-down now that you select if I can be interrupted by transition in the source or the destination state, or both, or just leave the transition atomic like before. We also, I don't know if you guys seen the blog post that I did a couple weeks back, but we had a discussion about default values in Mecanim. Currently, in the previous version, Mecanim would always write back all parameters, even if they were not animated in a state. Now you have the toggle for each state to decide if you want to go back to the default value or just keep the current values. This is super useful when you're going to do GUI with Mecanim. We also added a new type of blending, velocity blending. I will show it to you a bit later. We added an animator gizmo, and as you've seen, we have the previewer for panning and zooming. So let's take a look at these other small features that we've added. So here. So here I will activate the IK. So if you played a bit with the IK, you will not be surprised that you can do things like this. It's a bit ugly, like this, like this, like this. So the way that the IK solver used to work in 4.0 is that it always used for the shoulder here, it would use the roll that is coming from the animation. So the IK would always find the solution that is closest to the FK, the animation. But now we added the ability here to specify what we call an IK hint. Here I created an object to do the IK hint. And it allows you to control the roll of the IK. So if you want to do some crazy IK stuff, like this, which doesn't make sense, you can do it now. And we put a weight on that also, so that if you want to start from the FK and slowly add the effect of the int, there's a weight here that you can specify. So you see, maybe it's a bit, let's do it extreme. Here. So here it's based on FK, and here, so you can weight it in and out of it. Again, we work so that it is super simple. Let's take a look here. So this is the API for the IK, the API that if you tried it, it did not change. But we also added API to set the IK in position and the position weight. So again, very simple for those who have used it. Another thing, I spoke a little bit about it, is the linear speed blending. So this is a bit complicated. I'll try to explain it as well as I can, but the way that we used to blend the root motion of the character was based on position only. So what would happen is that if you blend, I'm going to show it to you, in fact. I'm going to go into running here. So here the character is walking. And I have a little script here that displays the speed of the character. Currently, he is going at 1 meter per second. Let's make him run. So now he's going at around 5 meters a second, which is very fast. Let me just disable the IK unless he looks kind of broken. So let's do this. So, and now he's running at 5 meters per second. So normally, if you would put 50% of it, it would be a blend between walk and run. But the way that we compute the interpolation between the walking and the running is based on position, like the root position of the walk and the root position of the run. And it doesn't blend linearly the speed. So here I'm 50% of both, and I have a speed that is around 2.5. So for those of you who are super good in math, you know that the average between 1 and 5 is 3. So it doesn't really work. So we added the ability, again, super simple. In the animator API, you just set to interpolate the velocity in a linear way. So if I activate it, you see that this is 3. So it's running at the proper speed. So for games that it's super important that you always fully control the speed of your character, and you don't want to manually or with code change the root motion of your character. You set this up, and you know that 50% between a clip that is going at a certain speed and another speed is going to be precisely the average of those two clips. So it's sometimes very useful to have that. And another thing that I skipped over that I wanted to talk a bit about, just give me a second, it's the lookat script that I put inside of. I think that lookat, I don't know if you guys are using it, but you should, because I think that our lookat algorithm is pretty powerful and easy to use. So let's go back here. So this is without the lookat. You see that the character is really not caring about where the crosshair is currently. So let's activate the lookat here, and you see that his eyes, let's just make him a bit more happy so that we see his eyes. So you see that his eyes are always precisely looking at the crosshair, while the head is not exactly aiming at looking at the crosshair, and the upper body here is a bit being affected, but not completely. So the way that this works, again, we try to make it very simple yet powerful, is that you set the lookat position here based on the crosshair, and we have here, you put the overall weight, and then you can put different weights for the chest, for the neck, and for the eyes. So this is a good recipe to make it look nice, is that you always want to have the eyes that are 100% looking at the target. You want to have the head at 70% so that it's turning a little bit, but not too much. And the chest, just so that it's influenced a little bit, you put a 50% weight. So this recipe makes it super nice, I think. So when you look at it, it kind of really makes sense. And the rest of the body is still completely controlled by the animation. So I think I ran really quickly because this is the type of person that I am. I always speak very quickly. So I guess I'll have time for a QA. That's all I had to show for today. So if you have questions, I'll be more than happy to answer them right now. Thanks. No questions? Cool. There's a microphone here, I think.
So for Unity 5, I noticed, as you've always been able to do, you're adding events to the animation for the sprite-based animation. Are we going to be able to add events to a 3D animation like what's in Mecanim, so that, say you're taking a drink of a glass of water, once you start it, maybe set the take drink to false so that when you're done, you don't take the drink again and keep looping?
But this has been there since 4.3, I think. The parameter that you create, set it to a trigger type, and it will automatically be reset to false when the transition is taken.
That sounds nice.
Yeah, it's in 4.3.
Okay, so that solves that problem. What about just kind of a regular animation event to where when you get to a certain thing, say trigger water splashing out of the cup or something?
I've shown it for the explosion sprite.
Was that being triggered? But that was being triggered by a regular animation, right?
Yeah.
Not by a...
Oh, no, it was a Mecanim. There's not so much difference between regular animation and Mecanim animation.
I guess I just didn't notice the difference.
Yeah.
I saw what you did there.
OK, so...
Cool.
You can even have the animation events talk to the State Machine Behaviour script and do some kind of interaction with each other, so it's kind of powerful also. More questions? I guess, thanks.
So you mentioned being able to use the state machines for all kinds of behavior not related to animations. Does that mean that you're actually able to run and use the animation state machines outside of an actual animator component?
It still has to be into the animator component, but you just don't put any animation in it, and it's not a state machine, an animation state machine anymore. Hi.
Is any of the API accessible at runtime?
So sadly, no. The API for creation is only editor only. We did it this way to be very optimal. It might change in the future because many people are requesting it to be able to do that at runtime. So at the moment, it's editor only. All right, so thanks for your time. And come and see me if you have more questions. Thank you. Thanks.